Podemos pasar ya a la última charla, que yo creo que va a ser muy amena. Estamos hablando ahora, en este caso cambiamos completamente de tema. Va a ser José Manuel Vaquero, que directamente de Universidad de Extremadura nos va a contar sobre manchas solares desde un punto de vista histórico. En ese sentido, yo quiero aprovechar mis 3 segundos de alguna manera para deciros que justo el año próximo va a ser los 100 años, por tanto, el centenario del nacimiento de la doctora Asunción Catalá, que durante el año 1957, por tanto, de manera muy histórica, sacó 4 imágenes de las manchas solares diarios durante el año internacional geodésico de toda la colaboración. Por tanto, es un tema interesante verlo desde el punto de vista histórico y desde el punto de vista científico que eso acarrea. Gracias.
Thank you very much. Muchísimas gracias a Minia, a la Sociedad Española de Astronomía, por este magnífico encuentro. Y bueno, cambio al inglés y comienzo mi presentación, pero que sepa el público que estoy muy agradecido. I am going to speak about the records of observations. And I would like to start with this image of this petroglyph. It is an engraving in a rock. This is located in the Chaco Canyon, in the wilderness of the southwest of the USA. And this is a typical representation of the Pueblo culture. More or less 1 millennium ago. My colleague, Professor Melville, proposed that this is a representation of the solar corona during a total solar eclipse. Why? Because if you compute the path of the solar eclipse of the 11th of July in the year 197, the path crossed the Chaco Canyon, just more or less in the time of the datation of this kind of petroglyph. I am basically, in a nutshell, I am a climatologist interested in the solar activity. And I was very interested to study the solar activity during the medieval climate anomaly. Then, by this reason, I called to Melville explaining, I can check if your suggestion is false, is erroneous, because the solar corona is very different. The shape of the solar corona is very different from a minimum of solar activity or in a maximum of solar activity. You can see, for example, some drawings during the minimum. This is the sunspot number, the solar cycle. During the minimum, you have these equatorial streamers, and in the maximum, the shape is quite different. Obviously, this is a corona of a maximum. Well, you can see in this figure the different solar maximums, and exactly they are a solar maximum just in the date of the eclipse. Therefore, maybe Professor Melville is right, and this is a representation of the solar corona 1 millennium ago. In fact, you can see here maybe the first coronal mass ejection recorded in history. For me, this is something incredible. But the referee too had other opinion, and then this result was not published in a important journal, was published in a minor journal, if we can see polite, Mediterranean archaeology. Well, this is an example of the beautiful things that we can find in the history. This is more or less the index of my presentation. I will talk about the Maunder minimum as an old paradigm of the solar terrestrial physics. Obviously, the sun was not the origin of the Little Ice Age, and the sun is not the origin of the global warming. I will speak also about the measurements of solar radius, and we will visit briefly San Petronio in Italy and San Fernando in Spain. I will speak obviously about the sunspot number. That is the classical example of the use of this kind of records. And finally, I will speak about the first prediction of space weather that was published in Cádiz in 1818, a lot of time ago. Beautiful picture. This is, if you read a book about the Maunder minimum, normally you can see this picture or other similar. This is Hunter in the Snow by Pieter Bruegel the Elder. And this is very nice. Europe during the Little Ice Age. But there are problems. You can see the date. The date is 1 century before the Maunder minimum. This does not agree. The sun is not the responsible, the origin of the Little Ice Age. 48 years ago, John Eddy published this seminal paper about the Maunder minimum. And some colleagues think that this paper is in his midlife crisis. In the last 10 years, in the community, there are two opposite visions. The first, Nadezhda Zolotova and Dmitry Ponjavin, established that the Maunder minimum is not as grand as it seems to be, and in other side, a big part of the community think that the Maunder minimum was indeed a grand minimum. The idea of Nadezhda Zolotova and Dmitry Ponjavin is very nice, because obviously the observations made by scientists also depend of the ideas of the society in their time. Then Nadezhda established that the astronomers in the 17th century are expecting round spots because they are looking for planetary transits. Yes, it is really interesting. We can jump this for questions. However, if you go to the historical documents, you can find things like this. This is a sunspot observed by one of the Cassini in the Maunder minimum, and this spot has a hexagonal shape. How it is possible? Well, you can see this image in 2016, and you can see also a spot more or less with a hexagonal shape. Therefore, you can find in historical documents round spot and also other spot. I think that Nadezhda is round in this assertion. It's very interesting that the idea of the Maunder minimum is a long period, more or less from 1645 to 1715, without a spot or very, very few spots without the solar cycle. But if you choose the data in the Hoyt-Schatten original database and you choose subset of this database, subset based in quality criteria, you recover the solar cycle during the Maunder minimum. And this is very interesting. And this solar cycle is shorter, 9 years approximately, not 11 years. You can see here in active take fraction or reconstructing the sunspot number, you can see the solar cycle during the Maunder minimum. We started a revision of different historical sources to study the Maunder minimum. For example, this very beautiful book is the Machina Ecolestic by the Poland astronomer Johann Hevelius. And you have a chapter in this book, an appendix really, with very detailed sunspot observations. There are also very detailed sunspot drawings. You can see, for example, the first line, the day 26 of 1642, October, in the sun, no spot appeared. A day with zero spot in the sun. Another important historical source is the Selenographia, also by Hevelius. This is a very famous book because it's the first scientific treatise about the moon, with a very beautiful drawings of the moon in different days. But in the appendix, we have a very important collection of sunspot observations and sunspot drawings. You can see, for example, in this English translation, it has been carefully determined its magnitude, proportion, and distance, and its color, density, nuclei, umbrae, and another element of this style. And it's really, Hevelius invented, created a lot of different words to refer to sunspot and facular regions. In brief, after this revision of the solar data during the Maunder minimum, we think that the order of magnitude of the sunspot number during the Maunder minimum is here, not in the extreme of proposed by Solotov and Ponjabin, not the idea of Hoyt-Schatten without the solar cycle, more or less around 10 in the sunspot number. Note that it's very important that the reconstruction of isotopes, the high resolution reconstruction with isotope very recently, two years ago, agree with this idea. We go now to Bologna, Italy. This is this nice figure by Paco Bellido, thank you very much. Is the meridian line of the Basilica of San Petronio. At the midday, you can see the sun in crossing this meridian line. And the Catholic Church used these huge cathedrals as a camera oscura, as dark room to study the astrometry of the sun. Fortunately, an Italian astronomer, Eustachio Manfredi, published all the data in a book. Then you have only use a machine-readable version of this data, and you have here this data from no tengo las gafas, from 1665, todo hacerse viejo, to 1737. You can see that the series is very noisy, But in this part, with a lot of observations, you can see clearly the variation of the solar radius depending of the Sun-Earth distance. This is the apparent solar diameter. Okay. This is very interesting because we can compare the data during the modern minimum and the data in the 18th century. If you analyze these two subsets of this data, we conclude that there is no difference between the solar diameter during the modern minimum and for the subsequent period of observation. And from the point of view of the astrophysics, astrophysics and geophysics, this is a very important result. We jump to Spain, to San Fernando. This is the observatory of San Fernando in early 19th century. And in this observatory, astronomers made astrometric observation of the sun during centuries. We have a lot of information about the historical instrument use, and this is very, very useful to make the correction to the raw data. The result is here. We undertook a time-consuming task to locate and recover a lot of observations. Note that the archive, the historical archive of this observatory has more than 4,000 books of documentation. And this is a tarea de chinos. And you can see our final result. These solar observations are evidence that the solar diameter did not change in the last quarter of millennium. Nobody expects other thing, but these are observations. It is not theory, it is not model, these are observations. We can now speak briefly about the sunspot number. In 2015, the situation in the community that we have two different series of the sunspot number for the last 4 centuries, based in telescopic counting of sunspots. The group sunspot number by Hoyt and Schatten with the modern minimum, and the international sunspot number in the tradition of Rudolf Wolf in red. The idea was to establish one unique time series to represent the solar activity in the past. And I think that more or less we did it. You can see using the ideas of Rudolf Wolf, the red line, the sunspot number, using the ideas of Hoyt and Schatten, the group number, and more or less agree. However, I must to say that our attempt was a disaster, because from one series we have now a lot of different reconstruction of solar activity in the past. During the last 2 centuries, all these series are very similar, but in the 19th century and in the 18th centuries, the time series disagrees. And this is due to the data. You can see in this panel the networks of overlapping observers, and we have overlapping observers in the last two centuries, but we have a very poor statistics in the 17th and 18th centuries. We can also obtain the butterfly diagram with this important asymmetry during the hemispheric asymmetry during the modern minimum. Well, the key is in the data. We publish a revised collection of the sunspot group numbers, and our next main goal is improve this revised collection. we are very interested in observations during the 19th and 18th centuries. We are looking for a long series of observations to obtain good statistics, and also we try to improve the database also with obtaining the number of individual spots, the sunspot position to improve the butterfly diagram. We recover also sunspot area and of course sunspot catalogs. Well, we have made a lot of work and I will only present 3 examples briefly. The first example is about the first telescopic observations in the Galileo times, revising the publication made by the Jesuit Christopher Scheiner. This is the situation in our revised collection. The solar cycle the shape is not very good, but after our revision, you have a shape more realistic of the solar cycle. We are also very interested in the Dalton minimum in early 19th century. This set of small amplitude solar cycle is not considered a grand minimum, and we recover a lot of very beautiful observations from a lot of observers in the archive of scientific institution, and we have now a better shape of the solar cycle during the modern minimum. Another example, Sacramento Peak Observatory has a very nice collection of sunspot drawings, full disk, and otra tarea de chinos. We were reducing all these drawings, and the result is very, very good. We have a lot of observations per year, and the comparison between the sunspot number that we obtain with the SAC peak observations and the standard, the international sunspot number, is very good, is very nice. What is the future? Well, I can read, but because it is very, very important, at least for me. We are optimistic that the coming decade will see significant improvement in our assessment of long-term solar variability and its associated uncertainty. However, this is very important, no amount of sophisticated algorithm will be a substitute for the identification and proper translation of historical documents, as well as for interdisciplinary teams involving astrophysicists, historians of science, and philologists to revisit historical observations of sunspot. The problem in our reconstruction is that our databases are poor. The future, well, in brief, this is the image of the future. We have a huge task, and we are the ants. I think that I have time for the last part of my presentation, and I would like to show briefly this episode in the history of astronomy in Spain. You can see the Real Observatorio de Madrid, and you can see the reconstruction of the Herschel telescope. This is the big science in Spain in the early 19th century. I would like to speak about Francisco Martínez de la Escalera. We don't know nothing about these astronomers. The official biography from the book of López Arroyo on the history of this observatory only said, adjunto del astrónomo, associate professor at the Herschel Telescope Department since 1804. After the Napoleonic War, he was a professor, a teacher, at the military college established in Murcia, and later moved to Jaén. No more. But remember that I am a climatologist. I was looking for meteorological data in all newspapers, and I discovered this small article, and this small article is an announcement of the sunspot that will present the sun in these years of 1818. This is the first prediction of space weather in the history. This is very nice. It's very short. Toda la vida para saber qué era esto, su sincero servidor que sus manos besas, Francisco de la Escalera. Y luego nos preocupamos por la materia oscura. Okay, I discovered a lot of articles in newspaper by Francisco Martínez de la Escalera explaining that he discovered a phenomenon celeste, celestial phenomenon, in several newspapers. He never divulgated the true nature. First, I thought, this is the solar cycle. No, it's not the solar cycle. It's more related with the position of the planets. Also, it's very important that Francisco Martínez de la Escalera observed sunspots and made meteorological observations during a lot of years. And he obtained his idea from these observations. And these observations are lost. I think that we can learn a lot of things about this episode. First, that data is better than warm or incomplete theories, and we can ask, what do we do to preserve our observations, our data, even our hypotheses or ideas? We can also learn a lot about the nature of the solar activity cycle. The paradigm, when I was a boy, the paradigm was the solar magnetism, but in the recent years, is emerging the idea of a planetary influence, the torque of the planets in the tachoclines, and this is something, this is not astrology, this is science. We can also learn about the nature of scientific activity, because we are talking about a proposal that is, I think that is very important, but from Jaén, in a peripheral place in the scientific world at that time. Que no se enfaden los de Jaén, que yo soy de Badajoz. O sea que... And also very important about the publications and the priorities in science. Well, this is the conclusion of my talk. Very important. You have to know the past to understand the present. And with this wonderful sound dial, thank you very much for your attention.
So thank you to you, José Manuel, for the amount of work you are doing here in this history. So it's time for one question. Here there is one question. Listen.
Very nice talk. You have talked about Apelles, Christoph Schneider, and his observations just after the use of the telescope. But at the same time, there are others, like Thomas Harriot in England, or Fabricius, or Galileo himself. What about their observations? And you have studied them, and it's the beginning of the 17th century. And obviously, Apelles one and probably the more known, but there were other people looking at the sun with the first telescopes.
Yeah, it is incredible, but there are a huge number of observers in the early times. We have the classical observers, the four co-discoverers of the sunspot, but there are a lot of people look in the sun with a new toy, the telescope, even in Spain and in Portugal. It is incredible. The problem is the data. You need the drawing of the solar disk, you need or a description, but in general it's very difficult to use the textual description to provide a good quantitative information about the level of the solar activity. And this is the main problem. In fact, I think that it's very important to study the people count the spot, but it's more easy. There are spots on the sun or no? The basic information, the one dimension, no or yes. And this is, I think that this is important. A lot of works in the last year are made with the base of the active day fraction, the fraction of days with a spot in the sun. No, okay, thank you.
Thank you very much. We do not have time for more questions, so we are here. So thank you to all these